Hey everyone, today we'll be going over Leetcode Problem 3, longest substring without repeating characters. In this problem, we are given a string s, and what we want to do is find the length of the longest substring without repeating characters. I have redrawn the example given to us over here on the side. Now, the most obvious way to approach this problem would be to take into consideration every possible substring in the string s, and see which is the longest without repeating characters. Now, the brute force way of doing this would be to find every substring of s, which starts with every single character in the string. So we would start, for example, with the letter A, which is the first character in the string. And we would go and find every substring starting with A. So we have the A itself, AB, ABC, ABCA, ABCAB, and so on for the remaining of the characters. We would then move on to the next character, B, and find every possible substring which starts with the letter B. So we have the B itself, BC, BCA, BCAB, BCABC, and so on for the remaining of the characters. And we would do this for every character in the string S. Now, in order to achieve this and get every possible substring, we would need two for loops nested, and so it would be an O of n squared time complexity. And then we would have to find which is the longest without any repeating characters. However, we can see that in using this approach, we do a lot of repeated work. In fact, when we start with the letter A, we have the string A, which we know has no repeated characters. Then we have AB, and we find that there's no repeated characters there as well. Same with ABC. However, when we add the A for the string ABCA, we know that we have a repeated character because we have an A which is repeated twice. Therefore, from this point on, when going to check the remainder of the strings, for example, ABCAB, we would know that even the subsequent strings would have repeating characters because of that same A that we already found. Therefore, we're doing some repeated work, and we could optimize this approach by instead using a sliding window approach. So as we just said, our optimal solution would include using a sliding window approach, and this allows to optimize our solution to a linear time complexity. We would start off by having two pointers, a left pointer and a right pointer. And we could start those both off at the beginning of the array. If at the beginning of every iteration, the letter pointed by R is not in our set, which will maintain all of the current characters in our substring, then we will go and add that to our set. So for example, we start off on our first iteration, and we see that the A is not in our set. So we will go and add the A in our set to go and indicate that we do in fact have an A in our current substring. After which, we can go and move our right pointer by one position. At this point, the right pointer points at a B, and once again, the B is not currently in our set, meaning that it is not in our substring, so we still have no repeating characters. So what we'll do is go and add B in our set. And of course, each time we would check to see the length of our current substring. So for example, up until now, our current length would be 2. And we can also have a variable to indicate the max length of a substring with no repeating characters, which initially would have been 1 when adding the A, and now is 2 because of the B. Again, we move our pointer, B, and now it points to a C. So we have the left pointer still at A, but the right pointer is now at C. Again, we have no C in our set, so we know we still have not found any repeating characters. So we could add C to our set. Our current length goes up to 3, and our max length also goes up to 3. We then move our right pointer once again, and we have approached an A. Now we go and check, and we see that we already have an A in our set, which means that we have an A in our current substring. So what we will do in this case is go and remove characters from our set, starting from where the left pointer currently is. So we said our left pointer was put at A and it was not moved yet. So what we go and do is remove the letter that the L pointer points to from our set, and then move the left pointer in order to shorten our substring. So we're going to go and move A because L points to A, and A will no longer be in our set. It is no longer in our current substring, so we move the left pointer by 1. At this point, our current length decrements. It goes from a 3 to a 2, because we now have only 2 letters in our current substring. Our max length, however, remains the same. Now what we do is go back to our right pointer and see if the letter pointed by the right pointer is still in our set. Now we see that the A is no longer in our set, so we can go and add it to our set, increase our current length by 1, and our max length has not been beat. It still remains 3. At this point, we can move our right pointer once again, and our right pointer now points to a B. So again, when trying to add the B to the set, we see that the B is already in the set. So we're going to have to remove characters from our left pointer side until we remove a B. So we see that the L points to a B, so we go and remove the B from our set, and then check to see again, has the character from R been removed? A B has been removed, there is no B's in our set anymore, so we can go and add the B back and move our right pointer to the next letter. And of course, having removed the B from the left pointer, we would also have to move our left pointer up by 1. Now we have a right pointer which points to a C, which is also in our set, so we're going to have to remove characters from our left pointer. Our left pointer points to a C, so we remove a C from our set. We move our left pointer by 1, and the left pointer now points to A. We decrement our current length from 3 to 2, and our max length still remains 3. We check again to see if the C is in our set. It is not, so we can go and add the C to our set and move our right pointer once again. And of course, we have to increment our current length again from 2 to 3. Now our right pointer points to a B, and so we have to check to see if we have a B in our set, which we do. So we have to check to see when adding the B to the set if it already exists in our set, meaning it is a repeating character in our substring. So we see that it is there, so we're going to have to remove characters from the L pointer. Now the L points to an A. So first thing we have to do is remove the A, decrement our current length to 2, and then check to see if the B has been removed. The B has still not been removed. So after moving our left pointer, we now have to remove the next character from the left side. And the next character is a B, finally. So we move the B, decrement our current length to 1, and again move our left pointer. We check once again to see if the B has been removed, and it has, so we can add the B from the right pointer and move our right pointer 1 position. And of course, we would increase our current length back to 2. And this process would continue until we reach the end of the string. And in this case, our solution would be in fact 3. The time complexity for this solution is O of n because we only traverse the string once with our 2 pointers. And furthermore, the space complexity is also O of n because of the set that we are creating, which can store characters. We can start off the code by taking care of 2 specific edge cases. We know that if the length of the string is 0, then what we could do is just return 0 because we know that if the string has no characters in it, then the longest substring without the repeating characters will also be 0. Furthermore, if the length of the string is 1, then because it is a singular character, we know that there will be no repeating characters possible, and so we can return 1. Then we could start by creating our character set, which will indicate the characters which are currently in our substring. We're going to start a left pointer and a right pointer, both at 0, as well as a current length and a max length, which are also 0 initially. Then we're going to start our while loop, and the while loop will run until the right pointer reaches the end of the string. Now what we want to do during each iteration is check to see if the character we are adding from the right side is currently in our substring, or currently in our char set, meaning that it is a repeated character. So while s of right is in char set, then what we want to do is remove, in this case, a character from the left side. until we remove the character that we're trying to add from the right side. And each time we remove a character from the left side, we need to increment our left pointer and decrement our current length. When we're done and can finally add the character from the right side, we could just go and add the character, increment our right pointer, increment our current length, and also check to see if we've beat our max length. After which, when we're done with the while loop, we could just return the max length that we found. Let's make sure this runs. And we see that it works. Thank you so much for watching this video. If you enjoyed it, please like and subscribe to my channel. I'll see you on the next one.